So I just give the step. Okay.
Doctor,
Uh,
I might ask a question about the tutorial one. I did, but I
tutorial
think
one.
tutorial
Which one?
I did, but I think I did wrong because the value is too small. So
Tutorial? Which tutorial? Tutorial
tutorial
8.
yeah.
Oh, okay,
A
okay. It's okay. So I just explain the step.
Oh, alright, thank you, Doctor.
What is the value you get?
And I calculate until the top is 0 point something, right? It's very low lah. So what the question I would like to ask is the above the when calculating the changes of heat from product, we need to get the delta A, delta B, delta C, delta D, right? Then since it's only for product, so if the reactants got if the reactant is excess, so the excess reactant is also considered as product also.
No, because this one is entering at 25 degrees C. So you don't have to consider the reactant. Okay.
So it means the delta A, delta B no need to get.
No need to calculate for the if your hypothetical part is like this one, right? Your hypothetical part is similar like previous example. If your hypothetical part, if enter is 200 degrees C, right? And leaving is maybe we don't know. We want to find the final temperature, right? So this one is delta HR. Okay, you bring it to the standard conditions, and then you calculate this one delta HR, this one delta HP. Okay, then you get delta H, right? This one is a delta H. This one delta H standard 298, right? So this one you have to consider the number of mole for the reactants, right? Okay.
Yes.
But if enter at this one, okay, enter at the standard condition is 25 degrees C. So you omit the delta HR. This one is no need. Okay, you're just starting from this one. Similar. This one. See? So we just use a delta HP lah. Okay, delta HP without the delta HR. Okay, and the number of mole we use is only for the product. This one is only for delta HP, not for delta HR. Okay, is it answer your questions or not?
Yes.
Okay, later for the tutorial 9, yes, you have to consider delta HR, and you have to calculate the number of moles for the enterings, the number of the reactants that enter the system. Okay, so you have to include delta HR and the number of mole. Okay, and you have to calculate the delta A, delta B, delta C, delta D for reactant and also for the product. Okay. Okay, let's redo for this one first. Yeah, I just give you the step, and you have to find the value. Okay. Okay. So I hope that you already read this one. Our target is to find the flame temperature, the final temperature for the ethylene at 25 degrees C. So what you have to do is first you have to know the reactions the equations. Okay. What you have to do is the reaction is C2. For those who already solve this one, okay, maybe I'm not sure the answer is wrong or correct. Just see this one, the procedure, the step 2, right? Okay, 2CO plus 2H2. Okay, so you have to know the equation. So what you have to do is you have to find delta H 298. Okay, so please remember you have to, what is it? Draw the hypothetical part first, okay? This one. Because we consider this is adiabatic, so delta H equal to 0. Right, and then delta HP. Oh, my God. P naught delta H 298. You see? Okay, this one is right turn. I just use the right R. Okay, this is the final temperature. Okay, and delta HP, right turn enter 1 bar. Okay, this one, and we consider as 1 bar lah. Although it's not mentioned, right? Okay, so we just consider 1 bar 25 degrees. Okay, we do the assumption. Okay, so please calculate 298 the delta H 298. Okay, from the heat of formation. So if you look at here that this is a what is it? Element, so it's equal to 0. So what you have to do is you have to determine the head formation for the C2H4 ethylene, CO, carbon monoxide, and also H2O. This is the vapor, okay? Yes. Okay, because the reaction is a vapor phase. Ethylene, I think even at the room temperature 25 degrees C, this is the gas phase, vapor phase. Okay. Okay. So once you determine, you have to calculate the number of mole. Okay, so please find delta H298. Okay, so number of mole that you say that theoretical amount of air at 25 degrees C, meaning that's 1 mole of ethylene react with 3 mole of oxygen. So entering, so of course it is burned with the presence of air, meaning that you have to calculate also the number of mole of the nitrogen. Okay, so since if you look at here that reactants, okay, I just reactants. Okay, C2H4 is equal to 1 mole. Okay, this one is 3 mole oxygen. Okay, for nitrogens you have to times with what is it? 25 21 divided by 79, right? Okay, times with how much? 3. Okay, so you have to calculate the number of mole. Okay, 79, sorry. Okay, 79 divided by 21 times with 3. Okay, 11. So meaning that since this is not only oxygen, but it should be air. Okay, so so 79 divided by 21, the number of nitrogen, times with 3 more. Because oxygen is 3 more, right? So you can get 11.29.
The product is CO2, is it?
Yeah, your product is CO.
Oh,
CO2
CO.
or CO2. Okay, sorry.
Okay.
CO2. Okay. And then for the products, this one P. Okay, I just use the P. Okay. So CO2 is 2 more. Same. Water 2 more. Since nitrogen is not react, this is going to be same. 11.29. Okay. So here and also here. Yeah. Okay, so you already got the number of mole. Okay. Is it clear? You have to determine this one, okay? So please calculate 298. This one already teach you how to calculate from the table B, C1 or B1. Okay. Is it clear this one? Okay. And next, what you have to do is you have to construct the tables, right? Okay. From the how many? 1, 2, 2, 2, 4. Okay, 4 lah, the element. Okay. And I, right? And then A, B, C, D lah. Okay. It's very short. It seems like 1 hour is very short. Already 20 minutes. Oh my god. Okay. So this one you just write lah. This one is the element lah. Direct oxygen. Is it? Or CO2. Okay, what else? H2O. Oh, sorry. Oxygen is 0 mole, right? Okay. Oxygen is 0 mole. 0 mole lah. Number of mole, okay. This one is 2. 2. So meaning that oxygen, if you don't want to calculate, is okay. And then nitrogen. Okay. What is it? 11 to 7. Oh yeah. 11.29 lah. Okay. And then A, B, C, and D. Okay. So this is no value. Okay. So just determine A, B, and also C, D, C and D. Okay. Okay. Is it clear this one? So this is for the product. You have to remember this is for product, because from the hypothetical part, if you still remember, it's just a triangle shape, right? It's enter at the standard conditions, but living at the that particular temperature lah that we want to find. Okay. Okay. So please find this A, B, C, and also D. So once you determine A, B, C, you have to determine delta A, H, delta B, delta C, and delta D. Okay. Okay, please determine this one. Okay, this is the next step. Okay. Yeah. Okay. So what's next? Okay, I show you. Once you determine delta A, delta B, delta C, and delta D, okay, just follow this step. Okay. So if you still remember that, delta HP, right? So delta HP, like this equation equal to summation of this one is T P naught, TP divided by R dt. Okay. So meaning that to delta H 298 plus delta HP lah, equal to 0. Okay. So just substitute this one into here. Okay, what I did is I bring this one to here lah. Okay. Because we know the value, this one, delta H 298, right? Because you calculate from the at the standard condition, right? So your equation is gonna be delta H equal to negative delta H 298. This time you know value. This one you substitute by using the integration. Okay. So I guess that the initial tau, because this one you need the what is it? If you still remember the IDCPH, okay, use the IDCPH because it's integration, right? Or you want to use mean heat capacity also is possible. Okay. Generally, you can use a mean heat capacity lah. Okay, this one I use, if I remember, I use this one by using integration and not the mean heat capacity, but possible both. Okay, and I choose tau T equal to T naught, or the initial tau is equal to 2. Okay, so T naught is 298, 25 degrees C, right? Okay, tau also meaning that the value of T is more than the initial temperature. Okay, T should be more than T naught. Okay, the initial gas. That's why I just guess T equal to 2. tau is equal to 2. Okay, tau, this is tau. Okay, so just substitute into the equations until the value on the left side of the equation and the right side of this one left and also right equation is similar. Okay, similar. Okay, you have to iterate until it's similar. Okay, can you do? What is the value of delta H 298? Anyone? Can you give me the answer? This one? At standard conditions? You can write at the chat box. Is it clear the step? Is it clear? Okay, for this delta HP, okay, delta HP, you have to use this one. Which equation? This one is similar. This one. Okay. Whether you want to use which equation? This one. This one, right? Okay. Or you want to use this one? It's okay. But I use this one. Use this one. Okay. For the delta HP. Okay. Can you give me the delta H 298? 132164. Okay. Okay, that's correct. Joule per mole, okay. 132.3164 joule per mole. Okay. Okay. Chow Yi already calculate. You can see from the chat box. Okay, delta H. Okay, please substitute into the equation and solve it. You already determined delta A, delta B, delta C, delta D, right? So meaning that delta HP equal to negative negative 132.3164 joule per mole. Okay, so what you have to do, you have to determine delta HP by using iteration. Tau equal to 2. Okay, what is the temperature? Find the temperature. Anyone calculate already? Already, anyone? That is the step. Anyone can give me the answer? So if you expand this one, okay, R A lah, T naught tau minus 1 plus B divided by 2 T naught. Because C is equal to 0, right? Okay. Tau minus 1 plus D divided by T naught. Okay. Tau minus 1 divided by tau equal to this one. Okay. 1, 3, 2, 3. 1, 6, 4. Okay. Okay. Or you want to iterate like this one also possible. You have to rearrange. Okay, in terms of T2 by using mean heat capacity. I think this one is much. I think this one is by using mean heat capacity. Yes, this one. Okay. I think by using mean heat capacity is much easier. Because it's if you look at here, right, you already what is it separate. It's they have already T minus T naught here. You just move it into the next to the left side. Oh, this one. I use this one. I think it's similar. Anyone can give me the answer? Anyone can give me the answer? Hmm. Wo Pohi? Poyi.
Auditor, I'm calculating.
Okay. Okay, that is a if theoretical amount. If 25% excess air, is similar. Okay, this is a similar like this one. Okay, so this one, delta H R is similar, but this is what you have to consider lah because it's stated that 25%, right? So if 25%, nitrogen will be this one is will be become because 1 with 3, right? 3 mole. 1 with 3 mole. Okay, 1 plus with 3 mole. Okay, to produce how many mole? 2 mole plus 2 mole. Okay, since there is an excess here, meaning that 1 plus 3.75. 75. Yalah, 25%. Okay. Satu, so kalau tahu 2, T0, 298, so dekat question HP ada unknown yang kena cari. You have to find T, final T. You have to rearrange that equation. Oh, Izzat. Izzat. HP apa unknown yang nak kena cari? Okay. No, because just now, this one, right? We already guessed tau equal to 2. When you use tau equal to 2, is it similar the answer between left and right? The answer is equal to 1, 3, 2, 3, 1, 6, 4, 0. Is it similar with the left side if you use tau equal to 0? If not similar, so you have to guess another value. Tau maybe is something with another value. Okay. This is when you do iteration, if you want to left side and right side is similar lah. But you can expand the equation in terms of t divided by t naught by using this one. The what is it? Mean heat capacity. Okay, it's already here. They have this one already. So you have to find t. Okay, just substitute to this equation. Okay. It's a similar lah like this one. When you rearrange. When you arrange in term T2, just substitute this one. What else? Delta HT. This one is delta HP lah. Right. This one you change. What else? This one change. This one change. This one change. This one the initial T you guess. Maybe 2 or 3. And then you can get the value of T2. Okay. Okay, any answer? Give me the answer. This one is chapter 6. Done. Okay. So this one is same lah. If 25%, you just follow this one. Okay. So 25. So 100, 1.2 times 3. 1.25 times 3. Okay. Okay. So if for 25%, oxygen enter how many number of mole? It should be because it's stated that 25%, right? So 125%, 125%, okay? Enter. Okay, meaning that equal to 1.25, right? Times with 3 mole. Okay, times with how many number of mole? Okay, 79. 79. This one is for the nitrogen lah. If for the oxygen, just 1.25 times with 3 lah. So you can get this one is for the nitrogen. For oxygen, just 1.25 times with 3. Okay, so you can get 3.75. Okay, this one is 14. Okay, and the rest is the same. Okay, So just follow like this one. Okay, this one oxygen, this one oxygen and nitrogen. Okay, is it clear this one? If 50% of number of mole, meaning that how many number? 1.5 lah, time with 3. Okay, 50%, right? So it's going to be 4.5. Yeah. Okay, so that is for tutorial 8. We have another 10 minutes or 15 minutes. Okay, let's move on. Doctor, ABC value is depend on which product? Exit lah, because it's product. The exit one what? Exit should be CO2, H2O. Oxygen is 0 mole. Okay, oxygen because it's 100%. And nitrogen lah. Okay, when exit. ABCD. Okay, so let's see for tutorial 9. Okay, so if you look at the ammonia gas enter the reactor to a nitric acid plant mixed with a 30% more dry air than is required for the complete conversion of the ammonia to nitric acid and water vapor. If the gases enter the reactor at 75 degrees C, if conversion 80%, if no reaction occur, and if the reactor operates adiabatically, what is the temperature of gas leaving the reactor? Okay. So this one. So if you look at here that you have this system, right? And H3. And then this one, temperature, starting temperature is at 75 degree lah. Enough. Right. What else? Excess. Dry air excess 30%. And then exit. NO, H2O. Okay. Conversion X sama dengan 80%. Okay, no side reaction. Delta H equal to 0. Okay, we have to find T. That one. This one dry air, okay? Entering 30%. Dry air enter. Okay. So basis, if you look at here that if you do the equations, right? So we just calculate, okay, for NH3 plus 5O2 okay, for NO plus 6H2O. Okay, so basis is a 4 mole of ammonia. So you said that 30% of dry air, all you have to do is you have to calculate similarly. Okay, from the equations, there will be a number of oxygen enter. So meaning that 1.3 times with 5. Okay, this is for oxygen. And then for nitrogen is 1.3 times with 5 times with 79 divided by 21. This one is for the nitrogen. Okay. So once you calculate, okay, this one, the entering and also exit going to be similar for the nitrogen, but for the oxygen, there is excess about 30% because it's react 5 with 4, right? Okay, what you have to do is you have to do the hypothetical part. Okay, so if you do hypothetical part, delta H equal to 0. Okay, this one is delta HP and delta HR. This one is delta H298 0. So this one is temperature at 298, 208. This one is T2. This one is 75 degree. Okay, so you have to find T2. Panjang. Okay. And then you have to consider this one HR. So meaning that delta H equal to delta HR, okay, plus delta H plus delta H equal to delta HR plus delta H 980 plus delta H in. Okay. This one you can determine. This one you can determine. This one you can determine. Okay. And then the number of mole that enter from the hypothetical part. Okay. So what you have to do, you have to calculate. Okay. If number of moles of the NH3 is because NH3 you have to consider 80%, okay, number of mole. So meaning that reacting lah. Okay. Okay, NH3 times with NH3 is equal to, because number of mole, our basis is 4 mole, 4 times with 0.8 lah. Only 3.2 mole reacting, and the rest will be exit as a non-reacting. Okay, non-reacting product. Okay, and then oxygen also similar. Okay, oxygen also you have to times with the 0.8. Okay, similarly also for the number of H2O form lah. Okay, this one is reacting. Okay. Oxygen also reacting 80%, as well as H2O also 80%. Reacting 80%. Okay. Ada berapa minit lagi? Okay. And then for the reactants, we have to determine A, B, C, and also D, right? Okay. Entering. Okay, when enter number of mole NH3 is equal to 4. Okay, number of mole. This one entering just now is reacting. So meaning that it's react 80%, meaning that 3.2 mole, and the leavings, the product is non-reacting reactant is 0.8 lah. So the leaving number of mole that leaving the system is equal to 0.8 for NH3. But this one is entering, okay? Not yet writing. Okay? Because we want to calculate delta HR. Oxygen equal to 6.5. Okay? And then nitrogen is equal to 24.45 mole. Okay? And then you have to find A, B, C, and also D. A, B, C, and D. Okay? So please determine this one. This is the step. Okay, A, B, C, and also D. And then you have to determine delta A, B, C, and D. Okay? We know the, what is it? The temperature at HR. Okay, 75 degree. Okay? So you can calculate delta HR. Okay? T naught is equal to 298 because at the standard conditions. Okay, and T1 is equal to 75 degrees C. You can calculate delta HR. Okay, okay, and next you have to calculate delta H 298 lah. 298 is equal to so oxygen is equal to 0. Okay, and H3 plus with oxygen and produce NO and also H2O. Okay, you can get the value of delta H298 lah. So please remember, since the conversion is equal to 80%, okay, so delta H298 is, you have to times with 80%. Okay, so you can get delta H, the actual delta H298. Okay, so this is for delta H2998. Okay, this is a step number 2 lah. Step number 1 delta HR. Step number 2 is delta H298. Next, you have to calculate delta HP. How to calculate delta HP? You have to determine number of moles. So leaving NH3 equal to the left, because reacting is only 80%, right? So leaving is 0.8 lah. 4 minus 3.2, 0.8 leaving. Oxygen, how much is reacting? So meaning that 80% reacting, so 6.5, right? 6.5 minus 4. Reacting is only 4. So leaving only 2.5. Okay. NO is equal to 3.2. Okay, H2O 4.8 lah. Okay. Leaving. And nitrogen lah. Nitrogen's same, no reaction. Okay. And then you have to determine A, B, C, and D. Okay. Almost. Okay. So by using energy balance, okay, by using energy balance, right? Okay, delta H equal to delta HR plus delta H298 plus delta HP equal to 0. Okay, just rearrange the equation. Delta HP, okay, equal to, because delta H equal to 0 adiabatic, right? And kita to delta H. This one. Previously, we didn't include this one, right? For the previous example. Now, since entering is 75 degrees C, so you have to consider delta H, HR. And then you have to do iteration to determine final. Okay. Any question about this step? Dapat tak? Any questions? Okay, ada soalan tak? Before we stop. So please do this tutorial. Okay. Generally for the test, it's gonna be this kind of questions. Okay. Okay. Any questions for the step? Because 1 hour, it seems, is a very short. So if you have no questions, it's already 5 o'clock. Okay. And for the next class, I will give lecture on the chapter 6. Okay. So what you're gonna learn for the chapter 6 is about you have to read what is the entropy. I will ask you what is the entropy. What do you understand about the entropy? I'm not sure about the Gibbs energy, I think. Yeah, Gibbs energy and so on. How to calculate the residual properties by using various cubic equation of state. I'm not sure is included or not. Okay. But generally we use this one. Generalized correlations, right? How to calculate the residual properties. Residual properties is like a correction for your calculation, because this one we didn't consider the residual properties. Once you include the residual properties, it's going to be more accurate your answer. Okay. So it's valid for the pure substance, single phase. Okay. That's all for today. Thank you very much. So please finish the tutorials and I will give you the assignment. So that's all. Thank you very much.